exponential equation. Show that the graph of ln y against x is passing through the origin. We have to show that it's a straight line graph. So this is now where we log both sides. So it's then ln y is equal to ln ax. And then it is ln y, which is equal to x ln a. Y is equal to mx plus c. Now you can see here that this is then the gradient. Ln a is m. And there is no c, but here they said it goes through the origin. So that is why there is no c, because it goes through the origin. Now, just to give you a picture, let's just draw this one a little bit here. This is then ln y against x. And now they say it passes through the point where x is 2 and ln y is 3. So it passes through this point, goes through the origin, but then it also passes through this point. So there's my graph, just to give me an idea what we are talking about here. Now we have to find the value of a correct to 2 decimal places, and this is what we're using now here. So I can say that ln a is equal to m, the gradient. And if you look now here, delta y over delta x, it is 3 over 2. So the gradient is 3 over 2. The slope is positive. So to unlock it, to ln it, we e it. So a is going to be e to the power of 1.5, that value there, e to the power of 1.5. And if you press your calculator, I get that a is equal to 4.48. 4.48. Just use my calculator. 2 decimal places, e to the power of 1.5. And then they say find the value of y when x is 5.2. So now we know that a is 4.48. And then it is just to that power of 5.2. This is just a calculation on your calculator. And my answer here is 2440. I rounded it off to 3 significant figures, so my answer there is 2440. Right, the next question is question 7. The variables x and y are related by the equation. So we always look at our exponential equation. I see that x is the base, so now I know that both axes will be locked. Show, can you see every time they ask this, show that the graph, but it is ln y against ln x is a straight line graph. This is how I know I have to use ln. So I'm going to ln both sides, and I'm going to say that ln y is equal to ln axb. Then ln y is equal to, because I multiply, I add, plus ln xb, and then I bring down the power. So ln y is equal to ln a plus b ln x plus b ln x. This is how I show that it is a straight line graph. It's also necessary to put this step in, y is equal to mx plus c. You need to see that and indicate which one is which one. That's what we want to see. This line meets the ln y axis, where ln y is 0.5, and the ln x axis, where x is 2. Now, let's draw that graph so that we get the idea. Both axes are ln y, ln x. We read it here. It cuts this axis when this is 0.5, so there, and the ln x axis where ln x is 2. So there. So it means that this graph looks like this. Can you see? And now I see it's negative. So that's why it's necessary for you to draw it. Although they don't say you have to do this. Find the value of a and b. This is what we need to find now here. I'm using this. Even if they don't say do this, use this method. And I start with ln A, which is equal to C. And where is that value? Here at 0.5. It's there at 0.5. Okay, so I need to unlock it, unlearn it. How do I do it? I use E. So E to the power of 0.5 there. And my answer is 1.65. They didn't say anything about rounding this time. Now we need to get the gradient. So what is the gradient? B is M. Can you see? B is M. Both axes are locked. So B is equal to M, is equal to the gradient. I see that my slope is negative, and it is then that delta Y over delta X. I do not need to unlock it because both axes are locked, or ln as in this case. It's very important that you use the negative, and it is then negative 0.25. That's my final answer there. Negative 0.25. Right, so now we're looking at question 8. Question 8. So now we're looking at question 8. Solve the equation 4 to the power of x is equal to 5. This is something you learned in grade 10 already. We're also going to log both sides. So what we do is we say log 4 to the power of x is equal to log 5. What I do on the one side, I can do on the other side. Then it becomes x log 4, which is equal to log 5. And then you divide here, so x is equal then to log 5, divide by log 4. We can just do that calculation on the calculator, and my answer is 1.16 there, 1.16. Right, now we're looking at number B. The variables x and y are such that the graph of log y against x is a straight line passing through the points. Find the equation of the straight line and hence find y in terms of x. Now, this time they gave you the graph and you have to go back to the equation. So we must remember that we're working here with logs. There's different ways to do this question. You can look here and say, okay, what is then the straight line graph's equation? Y is equal to mx plus c. So this is y is equal, my gradient is 1x, and my c is also 1. But now I need to change this then now to a log graph, remember? Because this is, you have to go back, so you need to change it to a log graph. So then y is equal to 10 to the power of x plus 1, because it was an exponential equation. So usually we start here and work backwards to the graph. Now we have to go the other way around here. And then they say, write down the value of y when x is 2. So we're just going to substitute a 2 in there, 10 to the power of 3 then, and the answer is 1,000. 1,000. Question 9. What do we have? Ln y against ln x. Both axes are ln. The variables are there, and we have those points. Find the equation of the straight line in the form ln y is equal to m ln x plus c. So ln y is equal to, what is the gradient? The gradient for this one now is negative 2 ln x, and what is c? Plus 6. So we can just read it off from that from the graph. The gradient is negative 2 ln x, and the y-intercept then 6. Now find the constants where y is equal to ax plus b. We can just use this here. So we already know And here it's always good to refer back to this one here. Can you see? To refer back to that one. So C is then the y-intercept. C is the y-intercept, which is that C. So we can say that ln A is equal to 6. You have to unlock it to unlearn it. How do we do it? We use e to the power of 6. That's how you unlearn that one. And this one rounds up to 403. And then we also have to get the gradient, and that's very easy. You can already see it here. You can see it here. The gradient m is -2. The gradient of b then is -2. Right, the last question for today, number 10. Now this one is exactly as the one that we did on top. You're going to log both sides, and we're going to say here x is equal to log 5 divided by log 2. That's very easy. You must just know the method, and I got 2.32 for that one. 2.32. Now here we come to a new thing now here. And this is just the log laws that we're going to use. But here they're asking it in a different way, and this is what we're specifically going to look at here. So I am going to use my log laws here. I'm going to insert a page, and this is then question 10b. Question 10b. So it is log y plus 5 plus log y plus 4 is equal to log 9y plus 27. Log 9y plus 9y plus 29. Okay, so I use my log laws. If I add, I multiply. So it becomes log y plus 5 times that y plus 4, which is equal to log 9y plus 29. And as we inserted now in A logs on both sides, we're going to cancel the logs now on both sides. What you do on the one side, you must do on the other side. Here I've got a trinomial here now, so it will be y squared plus 9y plus 20, which is equal to 9y plus 29, forms a trinomial, so y squared, this will cancel out, plus 49 is equal to, no, plus 9, sorry, it will cancel out there, plus 9 is equal to 0, if you bring that one over, so y squared is equal to, this one is a -9 here, but we can keep it there, and y is then equal to plus or minus 3. Y is then equal to plus or minus 3. Remember, if you root it, you need that plus or minus there. Right, thank you, grade 12s. That's then for today.
Bernardeschi for Juventus. Little touch from Ronaldo. Here he goes. Bernardeschi down inside the box. Referee has a look. It's a penalty. It's Ronaldo. It's 3. It's the record-equaling hat-trick of Cristiano Ronaldo's career.
With over 300 games in 6 weeks, get DStv to watch the best live football action.
12s. Today we're looking then at the last of the Cambridge questions. Here the syllabus changed in 2007 and we have now those new questions in here. It's mostly about the change of base. So we have to look at our log laws where we change the base. Right, but we start with number 11, solve it. So this is what we already did now in a few questions from here. X is equal to log 1.5 divide by log 3. And that is a calculation that you just do on your calculator. I have 0.369. We really should have these questions correct. Right, now we're looking at number B. The graph of log y, so this is the log axis against x, only one axis is log, is a straight line with a gradient -1 and it passes through the point 0,2. So this is the y-intercept 0,2 and the gradient is negative. So that is my picture. Draw it so that you can see. The variables x and y are related by this equation. Y is equal to ABX. Look again, x is the index, so only the log y axis is locked. That means I need to unlock my gradient. Find the values of A and B. Now this time they don't tell you to show that it's a straight line graph, but you need to do that, otherwise you won't be able to solve A and B. So I'm going to start here to say that log y is then equal to log A plus x log B. If I multiply, I add. So this is y is equal to mx plus c. And I indicate which one is which one. Which one is which one there. So let's start with this one always. So log A is equal to C. What is the value of C? Here I have it on my graph. So it is equal to 2. I need to unlock it to get the value of A. So A is then equal to 10 to the power of 2. 10 to the power of 2, and that is 100. 100. Now we need to find the gradient. Look here. There's your x and your x. So that means that log B is equal to m. Log B is equal to m. So log B is equal to, let's find the gradient, and they gave us the gradient. The gradient is -1. So that is then -1. I have to unlock it. So B is then equal to 10 to the power of -1, which is the same as 1 over 10 or 0.1. You can give any of those values for the correct answer there. Right, question 12. Solve log base 3 of 2x plus 1 is equal to 2 plus log 3x minus 11. Now the question is, can I solve it directly? No. What is the problem? The problem is this 2, because that is not logs, and everything must be logs before you can apply the log laws. And I need to change this one now to log base 3. This must become log base 3. Now remember, let's go back to 2 to the power of 3 is 8. Log base 2 of 8 is 3. Remember, when you're stuck, you go back to this. So where is this 3 now? That 3 is the index. This answer is the index. So it means that is the index. So we're looking at 3 to the power of 2 to find that value. And that's going to be 9. That's going to be 9 there. Right, I'm going to insert a page there for number 12 so that we can see better what we're doing. So we have now log 3 And then because I multiply, so it is 2x plus 1 is equal to, and we have now here log 3 of 9, and this is 3x minus 11. Okay? This is just plus. So now, because this should be log here also. So now because I add, I multiply. So it is then log 3, 2x plus 1, which is equal to now, so if you multiply there, you have log 3 of 9, 3x minus 11. Because I add, I multiply. Now I'm going to divide with this one here. So then I can say that this is log 3 of 2x plus 1. And I'm dividing now with that 3x minus 11 to have x on one side is equal to log 3 of 9. And now we can cancel the logs. As we added the logs, we cancel the logs. And now we just have to solve this equation. So it is then 2x plus 1. And this becomes then 27x. I multiply with the LCM minus 99. And if we solve this now, I have x is equal to 4. X is equal to 4. Right, now let's look at B. 2 log 5 of y minus 3 is equal to negative 4 log y of 5, where y is more than 0. Can I apply my log laws? No. You've got two problems. The one is the 3, and the other one is here. I have a change of base. And now I have to apply those log laws of the change of base. So this is now 12a2. So we have 2 log base 5 of y. Then you have the minus 3 is equal to sorry, let me just get the original one. Negative 4 over log y of 5. And let's first get now rid of that change of base. I need to change it to the same base, otherwise I cannot work with that one. So it is then 2 log 5 of y minus 3 is equal to, and what is the rule when you change the base? Then you can reciprocal it. So it is the negative 4 log base 5 of y. So it is the log law of the change of base. So when you change it here, you reciprocal it there. Okay? You can ask now, why didn't I change the 3? It is just easier to solve it without changing this one also to log base 5 of 125. You can do it, but it simplifies easier if we don't do that. So now I have, and I'm bringing this one over now. So I have 2 log 5 of y plus 4 log 5 of y, which makes it 6 log 5 of y is equal to 3. So I get the logs on one side, and I take the value of 3 there. Now I'm going to divide with the 6 here to get rid of this in front. So it's log 5 of y, which is equal to a half. Now again, let's go back to our rule. 2 to the power of 3 is 8. Log base 2 of 8 is 3. This is what we're going to use. Every time go back to that one. So I want y. So if I unlog this one, then I can say that y is equal to 5 to the power of a half. I'm just doing this. And this is the root, so it is the square root of 5 and the answer is 2.24. 2.24. Because it's logs, we will use the positive value then here on this one. Right, now we look at number B. The variables x and y are related by the equation y is equal to axn. Can you see that x is the base? So that means both axes are locked. And they say we have to show that it is a straight line graph. So we're again going to do this axn. So I lock both sides. Log y is equal to log a xn. Because I multiply, I add, so it will be log y, log a plus n log x. And we want to show that this is y is equal to mx plus c. Indicate which one is which one. You have to do that. Indicate which one is which one. Now, let's draw the picture. It will make it easier to understand. This is log y against log x. Both axes are locked. X is the base. And now they say this passes through the point 0, 2. So that will be the point there. And then 3, 3.5. 1, 2, 3. 3.5. There's the 3. So can you see that this graph has a positive slope? It has a positive slope. You have to draw the picture. And now they say find the value of a and n. So we're going to use this and our graph to find that. And again, log a is c. And what is the value of c? 2. The value of c is 2. So we have to unlock this one. You always have to unlock this one. So a is then 10 to the power of 2, which is 100. That's the value of a. Now, n is x. So we have to find the gradient. M is equal to n. Log x, x, both axes are locked. So we don't need to unlock that one. So what is this one's gradient? And I will use those points there, y2 minus y1 over x2 minus x1. So I can say that n, or the gradient then, 3.5